Imagine a land so dry, so brutally unforgiving, that men died of thirst within walking distance of gold, a place where water cost more than the ore pulled from the earth, where towns had erupted almost overnight from the red dust, desperate, trembling, sustained by little more than ambition and the staggering promise of mineral wealth beneath their feet. This was Western Australia's eastern goldfields in the 1890s, and the crisis it faced was not one of geology or economics, it was one of survival. The gold rush had come fast and hard. Tens of thousands of settlers flooded into the barren interior, drawn to Coolgardie and Kalgoorlie by reports of mineral wealth that staggered the imagination. These were not small towns. Kalgoorlie was already a city in waiting, raw, crowded, and growing by the day. But no one had planned for what came with the people. There was almost no water. What existed came from condensers that wrung moisture from the air, from sporadic and unreliable rainfall, from railway tanks hauled slowly across hundreds of kilometers of open desert. Waterborne disease was rampant. The cost of water was ruinous. Men who had come to make their fortunes were being slowly broken not by the earth, but by thirst. The communities that had sprouted from the dust were now threatening to wither back into it. Something had to be done, and done at a scale that had never been attempted before in this part of the world. The government of Western Australia could not ignore what was happening. On July 16, 1896, Premier John Forrest stood before the Western Australian Parliament and introduced a bill that would authorize borrowing £2.5 million, the equivalent of nearly 450 million Australian dollars today. The plan was audacious to the point of seeming reckless. A dam would be built on the Helena River near Mundaring, in the hills east of Perth. From that dam, a steel pipeline would carry fresh water across 530 kilometers of arid, sun-blasted terrain, climbing over the Darling Scarp and stretching all the way to Kalgoorlie. It would be the longest freshwater pipeline in the world. Nothing like it had ever been built anywhere on Earth. The man entrusted with that vision was Charles Yelverton O'Connor. He was the engineer-in-chief of Western Australia, Irish-born, meticulous, and possessed of an almost singular clarity of thought. O'Connor had already transformed Western Australia's harbour infrastructure. He had built Fremantle Harbour against considerable skepticism, dredging a passage through rock that many said could not be moved. He was not a man given to fantasy. He had looked at the maps, done the calculations, studied the geology, and concluded that a pipeline of this scale could be built. Not easily, not cheaply, but with precision, with will, and with time. The engineering challenges were immense, and each one compounded the next. The distance alone was staggering, 530 kilometers across country, with almost no settlements, no roads worthy of the name, and summer temperatures that pushed equipment and human endurance to their absolute limits. But distance was only the beginning of the problem. The water had to rise nearly 400 meters in elevation from the dam at Mundaring to the Goldfields. Because of the friction losses that occur inside a pressurized pipe over such enormous distances, the effective hydraulic head that had to be achieved was nearly 800 meters. This was not a problem that gravity could solve. It required mechanical intervention at scale, and it required that intervention to be sustained without interruption, year after year, across a largely unpopulated landscape. O'Connor's solution was a relay system of 8 pumping stations, spaced across the route, and each positioned to lift the water to a holding reservoir before the next station carried it further along the chain. Every station was designed with a spare pumping unit built in, because a failure in the middle of the desert was not an acceptable outcome. The first 4 stations, dealing with the steeper elevations near Perth and the Darling Scarp, required 2 pumping units running simultaneously just to meet the pressure demands of that initial climb. Stations 5 through 8, operating along the flatter interior grades, needed only 1. All the original pumping stations were powered by steam. That required fuel. That fuel was timber. And so, the pipeline route was deliberately aligned alongside the Eastern Railway, ensuring a reliable supply line for wood to fire the boilers. Communities grew up along that route, small settlements oriented entirely around the maintenance of the pumps and the pipeline. For a time, this infrastructure sustained a ribbon of human life across a landscape that otherwise had none. The pipe itself was a feat of coordinated local manufacturing. 60,000 individual pipe sections, each 760 millimeters in diameter, had to be produced and laid across hundreds of kilometers of desert terrain. Flat steel sheets were imported from Germany and the United States, then fabricated into sections on Australian soil. Meath and Ferguson was awarded the first contract and constructed a fabrication plant at Falkirk, now the Perth suburb of Maylands. C&G Hoskins established a second factory near Midland Junction. Between them, they produced the full complement of 60,000 pipes. James Simpson and Company supplied 3,500 tons of pumping equipment, arriving from abroad packed into 5,000 individual crates. The logistics of this project, by any measure, were extraordinary. Construction on the Mundaring Weir began in 1898. The dam itself was a major undertaking, a masonry structure built across the Helena River in the folds of the Darling Scarp, creating a reservoir that would serve as the scheme's beating heart. When it was completed in 1902, it was considered the highest overflow dam in the world. A dedicated railway line was even constructed to carry construction materials directly to the site. And yet, as the work advanced, the political ground beneath O'Connor's feet was shifting dangerously. He had powerful supporters, but his enemies were louder. Members of Parliament lined up to question the audacity of the project. Critics warned that the gold deposits would be exhausted before the pipeline was even finished, leaving the state buried under debt with nothing to repay it. The scheme was called a folly, an extravagance, an engineer's delusion. But it was the press that drew the deepest wound. Frederick Vosper, editor of the Sunday Times and himself a politician, mounted a sustained and merciless personal campaign against O'Connor. He questioned the man's integrity, he questioned his competence, he treated every delay, every technical adjustment, every cost revision as evidence of corruption or incompetence. O'Connor's most steadfast ally, Premier John Forrest, had departed for federal politics. The new Premier, George Leake, had long been an opponent of the scheme. O'Connor found himself increasingly alone, his reputation under assault, his character publicly savaged, his life's defining work treated in the public press as a national embarrassment. In March of 1902, Charles Yelverton O'Connor died by suicide. He was less than 12 months from seeing the first water reach Kalgoorlie. He died without knowing that he would be proven entirely, completely, and permanently right. His engineer-in-chief, C.S.R. Palmer, took the helm and guided the project through its final months. On January 22, 1903, Lady Forrest officially set the pumping machinery in motion at the first station at Mundaring. 2 days later, on January 24th, water flowed into the Mount Charlotte Reservoir at Kalgoorlie. The Goldfields had water. The desert had been answered. The pipeline worked exactly as O'Connor had said it would. The government inquiry that followed found no basis whatsoever for the allegations of corruption or wrongdoing that had been leveled against him. Every accusation Vosper had printed was found to be without foundation. The campaign that had contributed to breaking a great man had been built on nothing. The leaks that emerged in the early years of operation were a genuine challenge. By the early 1930s, an estimated 1.5 gigaliters of water per year was seeping from the pipeline, a significant proportion of total volume pumped. Maintenance and replacement work over subsequent decades addressed these losses. In the early 1950s, the Mundaring Weir wall was raised by nearly 10 meters, expanding the reservoir's capacity to meet a growing population. The legacy of the Goldfields water supply scheme reshaped an entire region. Branch extensions began as early as 1907, eventually reaching towns along the route and deep into the Great Southern. Today, the pipeline supplies water to more than 100,000 people, across more than 33,000 households, as well as mines and farms across Western Australia's vast interior. It has been named a National Engineering Landmark by Engineers Australia and an International Historic Civil Engineering Landmark by the American Society of Civil Engineers. The National Trust of Western Australia created heritage trails and guides along its length, a golden thread connecting the present to a moment of extraordinary human determination. A man died before the world could tell him he was right. But the water kept moving, 530 kilometers across the red earth, lifting, flowing, sustaining life where life had seemed impossible. A river of steel carrying the quiet verdict of history. If you found this history worth knowing, subscribe for more stories of human ambition in steel, stone, and concrete.